Hi, my name is Rosan and welcome to AHM. Okay, today's topic is about the time series project. Okay, so anyone who is trying to do transition towards data science or anyone searching for the job data science, so they can mention this project in their resume. Okay, and once they will mention this and they have to describe that in the interview, right? So you can come here and you can take the code from here. I'll be sharing that in GitHub. Okay, and after that they can describe this project to the interviewer. Okay, and about in the data scientist field, actually time series is a major topic. So that time series project must be there in your resume. Okay, so I'm creating one playlist. Okay, I'll be uploading like multiple time series project into that. Okay, and you can come there and you can check all the videos of mine. And if you are like those videos, and they you can take that. Okay, and you can check the codes from the GitHub also. Okay, so today's topic is like a prediction of the temperature. Okay, so it is a time series project. So time series project is like within a time particular period of time, so we have to predict the upcoming data. Okay, so that is called like time series project. Okay, so this data I have picked from the Kaggle. Okay, so code is like I have written already. Okay, so we just need to do run. So after that it will give some result. So like that we can proceed with this. Okay, so first is import warnings. Okay, so it will all like ignore the warnings. And after that, as usual, like numpy and pandas we did imported. And after that we'll trying to run this train and test. We'll read the data as a train data. Actually we need to train our model by using the train data. And test data actually we'll will figure out the prediction and the trend data, compare those data, and trying to find out how much accurate their model is. Okay, so the major topics in this, first is data loading. We'll do the data load, and after that we will do some EDA. Okay, and after that we will be building the models, like here ARIMA model, SARIMA model, and the AutoARIMA model. Okay, and after that we will choose which one is our best model. Okay, so later we'll discuss about all the advanced topics, advanced models like that models and the prophet model. Okay, so in this video we'll discuss only about ARIMA model, SARIMA model, and AutoARIMA model. Three models we will be creating. Okay, so first we'll go for the data. Okay, so I'll run the first code. Okay, so it will read the trend data and test data. Okay, so after that we'll check the top five rows of our trend data. Okay, we'll check the data here. So in this we have one date column and minimum temperature column and humidity and wind speed. Okay, and minimum pressure. Okay, so in this actually we need only the minimum temperature, and according to the date we need to predict the temperature. Okay, so it is all about per day. It has started on 2013. Okay, per day what is the temperature? Okay, minimum temperature. Okay, so it is all shown here. So it is about we'll check the tail part of here. Okay, next. So when I've checked the tail part, so it is started at 2013 from January 1st. So it is ended with 2017. Okay, January 1st. Okay, so it is all about the trend data. We'll train our model by using this data. Okay, but from these data we need only two columns. One is date and another is mean temperature. Okay, so according to the by the date only we'll predict the minimum temperature of that. Okay, so we'll check the test data here. Okay, in the test data we have started, it has started from the 2017 January 1st. Okay, So this data is already present in the in our train data. Okay, so first row it is already present in our train data, so that is I am mentioning here. Okay, so when we will check the length of our test data, okay, it is 1 on 4 rows. Okay, and for that I will be dropping one row, first row, zero row I will be dropping, because here in the test, in the trend data we have this data, like January 1st of 2017. Okay, here also in test data it is present here, so I am dropping the first row, so it will help us in further, like when we are doing, we'll compare with the trend data at, we'll compare with the test data and the like predicted data, so that will help us for measuring the confusion matrix, like error matrix. Okay, and that is we are using here MAC. Okay, mean squared error or mean percentage error. So if I'll delete this, so when I'll predict the um, sorry, so when I'll predict the prediction part of our model. Okay, so then we'll compare the test data and the predicted data. So after that we'll try to calculate the uh, error things like mean percentage error. Okay, so that's why I'm dropping this. Okay, so let's run this code. Okay, it's dropped. So we'll now check the length of our test data. Here it is already 1 on 3. Okay, let's check the head part here. Okay, so now it has been from Feb 2017. Okay, first date. Okay, not Feb, like, sorry, so it is the second Jan. Okay, so after that we need only date column and the minimum temperature column. So I am doing the training data and test data again by picking the date column and minimum temperature column. Okay, right. Then we'll go for the EDA part. Okay, in the EDA part we'll try to find out the, like, is there any null values or not. So this code is the for that. In the train data there is no null values. Okay, again for test data, yeah, this is also no null values, so this is fine for us. Okay, so we'll check the information about trend data. Okay, yeah, again it is showing the red column here, object, and the minimum temperature in the floor. Okay, so 1462 entries. Okay, so that is fine for us, no issues. Then we'll check for the trend test data information. Okay, it is also fine, it is also like object column and the float 64. Okay, and 1 on 3 columns over here, 1 on 3 rows, sorry. Okay, so if you are performing a time series project or anything time series activity. Okay, so better to convert the date column to a date time object. Okay, so that is I'm doing here. Okay, so I'm converting the date column in the trend data and test data both to a date time object. Okay, so this code will do that. Here it is showing object here. Okay, so now you can check here, it will be a dead time object. Okay, here dead time for trend data. Also we'll for check the test data. Okay, so it is also a, so fine, great. And we need to make that date column to our index. Okay, so for that I'm running this code, like it will do the in date column to the index. Okay, for the train and test also. Okay, then we'll check the head part of the train data. Okay, so it is already with the index column, date column, it moved to index. For the test it is also same. Let's see, yeah. So we have converted the date column to our index. So only we have minimum temperature here. Okay, so for further we'll try to predict the temperature. for onwards. Okay, for the test data. Okay, so for any EDF part we need to try to visualize something. Okay, and how our time series data is looks like. So for that, this code is we are using matplotlib and the C1 library, and this pile of parameters. Actually what it will do, it will fix the figure size of any our plot we are doing. Okay, so for that, we are plotting the trend data minimum temperature and test data minimum temperature. Okay, so let's run this code. Yeah, so okay, you can see here. Okay, so the time series data is like in this way. Okay, so it is all about the date mentioned here and the temperature in the y-axis. In the x-axis we have dates. Okay, so let's plot the trend data in a single frame. Okay, because it is mentioned, it is like both the data we have plotted, like trend data and test data. Okay, so here we will draw only the trend data plot. Okay, so here we have plotted the trend data. Okay, so in this actually you can easily see there is no trend. Okay, and only seasonality is there, because in the month of April or May, the temperature is very high, and starting of this January or last of the December to January, the temperature is very low. So there is a seasonality of here, monthly, not monthly, yearly seasonality. Okay, so we'll perform the first model of ARIMA here. Okay, so I did a deep copy of our data, so without like affecting our trend data. So I make one like variable data, and I've stored the all the data over here. So let's run this. Yeah, fine then. Okay, and here actually from starts model TSA, some ridiculous test we're going to do, because like every time series data, whenever we are doing some like any time series problem solving any time series problem. Okay, so there will be your time series should be a stationary data. Okay, without stationary, like you cannot perform the time series. Okay, so like the eddy flow test, it will show you like the your time series data is stationary or not. Okay, so for that I have created one like function which will test the time series stationary or not. Okay, so in that I have mentioned the moving average, like Windows 12 means it is like a yearly seasonality is there. Okay, for mean and for the standard deviation, and also will plot the figure. Okay, so how it is performing, and after that we'll do some like a fuller test, so it will show the the data is stationary or not. Okay, so let's run this code. Yeah, it is a function, it will give no result. Okay, so after that, from starts model TSA API, will import the SMT. Okay, and after that we'll decompose our like time series data. Okay, because after decomposing you can show in a like way like how your time series data is all about. Okay, so let's run this. Yeah, so here it is showing like your sorry, so here it is showing like your data is like it is like there is no trend, it is all about moving up and down here. Okay, and here seasonality is there. Okay, from this data is you can easily see this, and okay, and reside, it's not that. Okay, so we'll check the stationary stationarity. Okay, we'll check the stationary with this code. Okay, so in this code you can see like blue line is our original data and rolling mean, so it is all about varying. Okay, so as our original data, so it is all about varying, and the rolling standard deviation, it is like constant. Okay, So we should see all our data, like whatever data we are performing for the time series. So that should be like this. Okay, so it will be constant, so it will be perform very good while doing performing the like time series analysis. Okay, so we run this test stationary, okay, with the data of minimum temperature, and it's clearly showing that this function data is not stationary. Okay, so for making stationary we need to make apply different like different operations we can apply over here. And for this we have applied the difference operation over here. Okay, so data diff I have created and created one difference operation. Okay, so data diff I've created one data, and after that I've dropped the null values over here. Okay, so again I'm decomposing the our like data diff difference data that I have prepared from here. Okay, with the seasonality period up to 12 also here. So we'll see this differentiated data. Okay, so now it is like trend is almost constant over here, so not an issue. And here also seasonality also here constant over here, so not an issue. This is also fine. Okay, okay, we'll check the stationarity in the data diff. Okay, yeah. So you can clearly see over here like original data is constant over mean, and rolling mean also constant over, and rolling standard deviation is also constant. So this data is well now to perform the time series analysis. So we made one differentiate operation to making this data stationarity. Okay, so it is showing like data is stationarity. This function actually how we'll check with the p value. Okay, here the p value is 0.00. Okay, you understood, right? And here the p value is 0.28. Okay, so if the p value will be like 0.05 less than 0.05, so this data will be a stationary data. Okay, if p value is more than 0.05, this will be not a stationary. Okay, so that all edifuller test shows us. Okay, that is very helpful, like for making like the, if you trying to understand this data is a stationary data or not, that will perform by the edifuller test. Okay, that is called. So that decupuller test, it is also mentioned here. Okay, so now we have imported the like ACF and PACF chart. So it will, those will help us like to take the like a PDQ value. Okay, so whenever we are performing in a ARIMA model. Okay, so here we will plot the TS plot over here. Okay, let's run this code, and how this PACF and ACF perform we'll check here. Okay, this function is like build to like create the PCF and ACF chart. Okay, so TS plot and will data diff. First we'll check the differentiated what data we have made the differentiated. So that is the data here. Check with the TS plot function. Okay, here p value is 0.00. So we are performing the data differentiated data which we have prepared. Okay, so it is the partial autocorrelation. Okay, it is the p value, and autocorrelation it is the q value. Okay, from here we can pick the p value. So it is like all like approximately 3. Okay, 0 1 2 3 here, and here it is also like 1 2 3. Okay, so from here I am picking the pdq value here. Okay, so from this start models tra tsa arima model, I am imported the arima as arima. Okay, so ARIMA model, I'm mentioning the data diff, the data, and the order of the PDQ 303. Okay, so after that we will feed the ARIMA model. Okay, model ARIMA. Okay, ARIMA model dot fit. Thing is fancier. Okay, it's all about the code. So ARIMA model we did fit on our data diff. Okay, and after that the ARIMA diff prediction. Okay, whatever prediction we have to make with the differentiated data. Okay, so that I am mentioning ARIMA diff prediction. Okay, then ARIMA model dot fit dot predict, and the length will be the differentiated data. Okay, and plus will predict the future for 1 on 2, because our data length is 1 on 3. Test data length is here. One I checked, yeah, here it's 1 on 3. Okay, test data length. So for that we'll be predicting the 1 on 2 values, because we are manually putting the PDQ value. Okay, so it will not take the like it will not take the onwards 1 on 2 values. Okay, so for that we have mentioned 1 on 2 over here, so making prediction for the like uh, next 112 values. Okay, so let's run this code. Done. Okay, so let's check the ARIMA difference prediction head values. Okay, so it is showing 1.34. Okay, so it is all predicted from the 2nd Jan 2017. Okay, so it is prediction for the differentiated data, so we have to make it real. So ARIMA prediction, we made the data ARIMA prediction, then np.com sum. Okay, then we have mentioned the ARIMA deep prediction data. Okay, so then we are making that to our real data. Okay, then we check the tail part of the data. Okay, got it right. So it is 2017 to 11 Jan 2017 all about. Okay, so data tell it is ended with 1/1/2017. Then ARIMA prediction, when we will check the predicted data or predicted data, whatever ARIMA model has been predicted. Okay, that has been started from the 2nd Jan. Okay, the end date of our trend data is 1/1/2017, and we have predicted from the second. Okay, it is all about 11.34, 12.4. It's all about, we have already predicted, the ARIMA model has already predicted for the next 1 on 2 data. Okay, here we will check the ARIMA prediction tail data here. Okay, so it is all about the 4th of 24th of April 2017. Okay, so let's plot the data. So I'm plotting the 1000 onwards. Okay, so it will all capture the all things. See the model how it is performing. Okay, the prediction part is not performing well, here we can see. Okay, so let's check, let's plot with the test data here. Okay, see blue line is our test data, and the predicted data is our orange line. Okay, so you can see like this data is going in this way, and our prediction data is going in this way. Clearly it is showing like not prediction, not predicting well actually our model, ARIMA model. Okay, we'll check the test data shape here. 113. Okay, and 1, and ARIMA prediction shape here. Okay, 1 on, so it will be very it will be easily you can find out the like MAP. Okay, mean absolute percentage error here, we'll try to find out this. Okay, the value it is showing 0.35, not a good value actually. Okay, so we'll try our next model, SARIMA model over here. Okay, so let's start the model fitting. We have mentioned same thing over here. 303 PDQ value, and the seasonality order is like 303, also 12, because it is a yearly seasonality. So we have mentioned 12 over here. Okay. So SARIMA model got fitted. Okay. Then we will predicted the difference rate value. Okay. SARIMA diff prediction. Okay. And this will predict for the next one and two values actually. Okay. And after that we'll make the like original prediction for that SARIMA prediction. Okay. By doing some NP come sum. So it's fine now. We'll check the data tail values and SARIMA prediction head. It is also same here. Okay. It started at ended at 1117 and ending at 2nd Jan. Okay. Fine. Again we will plot this. See, it is also same like predicted in this way. Clearly it is showing not predicted that much of well actually. Okay. It is with the trend data. Okay. Main original data and the prediction of the data. Okay. Not behaving well. Same here. We'll compare with the test data here. Yeah. You can see the test data is going in this way and the predicted data is going in this way. Okay. Not fine. The mean absolute percentage error over here. It is showing 0.40. Here here it is 0.35. Okay. So actually it is not better than ARIMA. Okay. Let's try the AutoARIMA model over here. Okay. So AutoARIMA will performing the seasonality, making the seasonality false on first stationary data. So stationary we made by differencing the data. So on the differentiating data, we will apply the our like AutoARIMA model by making the here I mentioned differentiating data. Okay, seasonality false. We are mentioning over here. Okay, let's fit this model AutoARIMA model with seasonality false on stationary data. Okay, yeah, model got fitted. Okay, it has predicted 110 101, sorry 101. Okay, so then we will predict the next 113 values. Okay, so here there we have mentioned for ARIMA and SARIMA we have mentioned 112 values. Here we are predicting the 113 values because you know like we are mentioning the components. We are mentioning the like hyperparameters over there PDQ values like manually. Okay, so for that it will take the previous values. Like if you are trying to predict next 30 days, it will first take the like last value trend data value first, the last trend data value, and after that 29th prediction values, because we are like predicting like mentioning the PDQ values manually. But here the AutoARIMA it is pick the automatic values of PDQ. So it will automatically predict the next 113 values. Our test data length is 113. Okay, so let's run this. Okay, fast auto arima deep prediction value, it's the different prediction values. Okay, what you made the data by different setting. Okay, so it is the original value, fast auto arima model. Okay, arima model prediction values. Okay, so let's predict the original values. We can plot the fast auto arima, it is the fast auto arima model we have performed by making the seasonality false on stationary data. That's why I mentioned fast auto ARIMA model. Okay, let's plot this. Yeah, see, you can clearly see it is also not performing very good actually. Okay, same thing. And compare the test data, it is going in this way. It's not good actually. Okay, so let's find out the mean absolute percentage error. It is showing 35. Okay, so according to the arima model it shows 35, and sarima 40, and it is showing also 35. So not better than that actually. Okay, so let's the second AutoARIMA model. Okay, by making the seasonality true. Okay, let's see. Then we'll feed the second AutoARIMA model to our differential data. Okay, then predict the differentiated value, differentiated predicted value, and here it is our second AutoARIMA prediction value, original prediction values. Okay, predicted, then plot. See, it is not good at all actually. These models are not performing well. Okay, we have compared this with the test data. Test data is going in this way, or is line in the our prediction data. It is also same. We'll check the mean absolute percentage error, the matrix over here. It is also showing 35. Not better than that actually. Okay, so auto ARIMA model with seasonality, with seasonal false and non-stationary data. Non-stationary data is our original data. We made the differentiation operation for making the stationary. Okay, so we will perform directly with the non-stationary data. Let's see how it is behaves with making seasonal false. Okay, right. Then we'll feed this third auto ARIMA model over. Okay, then we have predicted the third auto ARIMA prediction values over here. Okay, then we'll plot with. Let's see how our model behaves. It is also same behavior, not good actually. Here we will compare with our test data and the prediction data. Third out our MEA model. Yeah, almost same. Here it's also like mean absolute percentage error is 35. Okay. So auto ARIMA model with seasonal true will make on stationary, non-stationary data. Okay. So let's run this fourth auto ARIMA model. Okay, great. Then we'll fit our model, fourth auto ARIMA model. Then we'll predict and try to plot. Here the same behavior. All those models are not performing well actually. We'll compare with the test data here. See, same behavior. not good actually. We check the mean absolute constant is error value. It is also showing 35. Okay, so below than that we cannot move actually. Okay, so 0.35 we should have like get much less value for this operation actually. So we'll make this try to apply all these other different models, or we can try to apply the different operations to make stationary the data. Okay, like we can apply the exponential or Fourier transfer for that. Okay, so make that data to stationary, and after that we can apply the models all again, try to find out the whichever is our best model. So what all models we have performed, like four AutoARIMA models and ARIMA model and SARIMA model. So between that, if you try to find out which model behaves good, so this code is for that. So let's run this. It is showing the best model is model 1. Model 1 means that ARIMA model. So whatever we have performed for this time series data, the first model has shown the better result for us. Okay, yeah. So thanks guys, this is all about this. So if you're trying to if you try to increase the like performance of this model, so you can try all those like whatever I mentioned, like in the previous, like you can apply the operations, different operation like exponential operation, or like the Fourier transform operation, and after that you can apply all these models again. Okay, so it will be better to you to like it might decrease the like the error, mean absolute percentage error, so to which will be like good for your model performance. Okay, so that's it guys, that's it guys. Okay, so we'll meet in the next video.